Let's look at a question from Delta Math that asks you to write the equation of the tangent line. And we're going to talk about some common ways to write it and kind of what's involved with this. So first, to write an equation of any line, you need a point and you need slope. Slope is the calculus piece. It's finding that derivative equation. So we're going to start with that. So we're going to write our limit as h goes to 0. And then you're going to put the f of x plus h into the function. So it's going to be negative 8x plus h squared minus 3x plus h plus 10 minus the original function. So that's minus the f of x. So negative 8x squared minus 3x plus 10 all over h. So I'm going to spend my most amount of my time just with the numerator. It's always going to be over h. It's always going to have a limit out front, but we've got a lot of algebra to do to clean it up. So I'm going to square out the x plus h. That's going to give me x squared plus 2xh plus h squared. I'm going to distribute the negative 3 actually, negative 3x and negative 3h. And then I'm going to distribute the negative in front of the entire function, which is going to give me a positive 8x squared, a positive 3x, and a negative 10. And then I'm going to go a step further and distribute this negative 8 to give me a negative 8x squared, a negative 16xh, a negative 8h squared, and then everything else that you see here, which if you want to rewrite it, you can, or if you just want to kind of start from there, that's fine too. And again, all of this is over h, and the whole thing has a limit as h goes to 0. So now we're going to start canceling. So I've got a negative 8x squared and a positive 8x squared. I've got a negative 3x and a positive 3x, and I've got a positive 10 and a negative 10. Usually you get some quick things that cancel. Next thing I notice is everything that did not cancel in the numerator still has an h in it. So I'm going to factor out that h, which leaves me with negative 16x minus 8h minus 3. So then the h that I factored out will cancel with the h in the bottom. And then finally, I want to take the limit of whatever is left as h goes to 0, which will wipe out this term. So when all that is said and done, we get negative 16x minus 3. That is referred to as the derivative of the function, the equation for how we find the slope of a tangent line. So all of that was done so we can find the slope at 5. That's the point they're talking about, the x value they're talking about. So you're going to put 5 in. Again, you can use a calculator if you want. So negative 16 times 5 minus 3 gives me a slope of negative 83. So we said at the very beginning of this problem, to write an equation of a line, we need a point and a slope. Well, we've got the slope, we've got the x, we need the y. So essentially what I have right now is I know x is 5, I need to know what y is. And anytime I need to know what y is and I have an equation, it's just a matter of plugging that x value into that equation. So again, if you want to grab a calculator just to save yourself the mental math, negative 8 times 5 squared minus 3 times 5 plus 10. And I get a y value of negative 205. You could also enter it in your calculator and use a table. There's a lot of ways to get your y value. So finally, writing the equation of the line. We have a lot of forms that you learn in Algebra 1. We have point slope, slope intercept, standard form. The one that I am going to prefer in calculus is to leave it in point slope form. Point slope form was y minus y1 equals your slope times x minus x1. And I know in Algebra 1, oftentimes if you left your answer in that form, the teacher would say, well, it's not done yet. In calculus, it's done. We want to leave it like that because we can get some really messy slopes and we don't want to do extra algebra. So my tangent line equation would be y minus 205, so y plus 205 equals a slope of negative 83, x minus 5. And that is a perfectly acceptable answer. And actually, in my mind, a preferred answer than cleaning it up more, distributing, getting y by itself, and writing it in mx plus b form. So that is how you go through the full process of writing a tangent line equation by using the derivative and the x value that was given.